have been doing. Okay, so you have your fractions. Now there's an equal sign, so it is an equation. It's not just an expression. So equations that contain one or more rational expressions are called rational equations. These equations are often easier to solve once the fractions are eliminated. You can eliminate the fractions by multiplying each side by the least common denominator. So that is what we're going to do. So you're multiplying each side by the least common denominator. Okay, when you do that, you cancel out all of the denominators and you can solve your equation like normal. Okay, so an example of this, we have 2 over x plus 3 over 2 is equal to 19 over 10. So my first step, step 1, is to find your least common denominator. To do that, you need to find the LCM of all three denominators. Okay, so one denominator here is x plus 3. Okay, I can't factor that. It just stays as x plus 3. Next denominator is 2. Again, I can't factor 2. It stays as 2. Last denominator is 10. Okay, I can factor 10. That would be 2 times 5. Okay, so to get our least common denominator, we take our first. Okay, so our first set here, our first factored version, that's x plus 3. Move to our second. Did I have a 2 yet? No, so I need to write times 2. Move to the third. I already have a 2, so I don't need another one. But I don't have a 5, so I need to multiply by a 5. Okay, we've done this before. So my least common denominator is 10 times x plus 3. So I'm going to multiply each of those fractions by 10 times x plus 3. Okay, so step 2 is to multiply each of those fractions by your least common denominator. So my first fraction is 2 over x plus 3. Okay, and I'm multiplying by my least common denominator, which is 10 times x plus 3. Okay, same thing with my second fraction. Okay, so I'm adding 3 over 2, multiply by your least common denominator of 10 times x plus 3. Okay, then I have that equal to, my last fraction is 19 over 10. So again, multiply that fraction by 10 times x plus 3. So again, by doing this, you're canceling out your denominators. So all three of your denominators should cancel out. So I have an x plus 3 and an x plus 3 in that first one. Those cancel. I have 10 over 2. Well, the 2 will cancel out. The 10 will change to what? 5. Okay, and in my last fraction here, I have 10 over 10, so those cancel out. Okay, so that's why I'm multiplying by that least common denominator. From here, I can just rewrite my equation. So I have 2 times 10 plus 3 times 5. Okay, that's still multiplied by x plus 3. Okay, don't forget about that one. Okay, and then is equal to 19 times x plus 3. Okay, so from here, we're just going to solve our equation for x like we normally would. So I can multiply 2 times 10 to get 20. Plus, I have 3 times 5 is 15 times the quantity x plus 3. And then here you have 19 times the quantity x plus 3. I would distribute that 19 to get 19x plus 57. Okay, here I still have to distribute this 15 to both x and 3. So we have 20 plus 15x plus 45 equal to 19x plus 57. I'm going to combine like terms, so I have 20 plus 45. That's 65. Okay, I can subtract 15x from both sides, right? That gives me 4x. And I can subtract 57 from both sides. That's 8. Okay, divide both sides by 4 to get x is 2. Now, before you circle or box your answer, you do need to check. Okay, you need to check that that makes sense. So, step 3 is check your answer. Okay, so I need to plug 2 in for x in my original equation here. Okay, so 2 in for x. So we would have 2 over 2 plus 3 halves is equal to 19 tenths. Okay, so this would be 2 fifths plus 3 halves equals 19 tenths. Now we need a common denominator between these two fractions in order to add them, right? Okay, that common denominator would be 10. So to change 5 to a 10, I multiply it by 2. So I'd also have to multiply the numerator by 2 to get 4 tenths. For that second fraction, I have to multiply by 5 in the numerator and denominator. So that is 15 tenths. Okay, and once I add them, I do get 19 tenths equals 19 tenths. Okay, that does work. So then I can circle or box that x equals 2. Okay, so these are your different steps. Step 1 is to find your least common denominator. 2 is to solve using that least common denominator. And 3 is to check your answer. Questions? Not so bad? All right, then, do we got that? Are we good? Yeah? Okay, so multiplying each side of an equation by the least common denominator of rational expressions can yield results that are not solutions of the original equation. Okay, these are extraneous solutions. Okay, this is why we have to check. Okay, you might result in an extraneous solution. So with our second example, that's what's going to happen. Okay, so here again, we want to do that same process using those 3 steps. So first step is to find the least common denominator. Okay, so here's our step 1. I need to take each of these denominators So I have x plus 5. Okay, that can't factor, so I would just keep it as x plus 5. Second denominator here is x squared plus 8x plus 15. Okay, that does factor. If you need to, use the x method to factor that. So what multiplies to 15 and adds to 8? 3 and 5. So I would have x plus 3 times x plus 5. Yes, I'm writing small because you need a lot of room here. Okay, last denominator is x plus 3. That one doesn't factor, so it would remain x plus 3. So then to get this least common denominator, or your least common multiple of all three, you take your first term, so the first factored version, which would be x plus 5. Look to your second factored denominator here. I don't have an x plus 3 yet, so I do need to write that down. But I already have an x plus 5, so I don't need another one. For my last denominator, it is x plus 3. I already have an x plus 3, so I don't need to write it down again. So this is your least common denominator, and you're going to multiply each of your fractions by that least common denominator. Okay, so looking at step 2. Okay, we're going to multiply each of these fractions by that least common denominator. So my first fraction here is 2x over x plus 5. So multiply by x plus 5 times x plus 3. Okay, moving to your next fraction, we're subtracting x squared minus x minus 10 over, I'm going to write this as the factored version, okay, which we already factored, so you don't have to refactor it. So I want to rewrite this as x plus 3 times x plus 5. Okay, that way when I multiply by the least common denominator, it's easier to cancel. Okay, and then the last fraction is 3 over x plus 3. Again, multiply that fraction by your least common denominator as well. So x plus 5 times x plus 3. Okay, now once I multiply each of these fractions by the least common denominator, all of those denominators should cancel out. So I have an x plus 5 over an x plus 5. I have x plus 5 over x plus 5 and x plus 3 over x plus 3. The last one, we cancel out the x plus 3's. Okay, so again, your denominators should always cancel out for these types of problems. So from here, I would have x plus 2 times what I have remaining, so x plus 3, okay, minus this quantity. I'm going to write it as a quantity because you do have to distribute that negative. That quantity of x squared minus x minus 10. I don't have anything extra. It all canceled out for me there. Is equal to, we have 3 times x plus 5. And again, from here, we're just going to solve like we normally would. So I would distribute 2x to both terms inside my parentheses. So we have 2x squared plus 6x. Distribute this negative to all three terms. So minus x squared plus x plus 10. And then distribute your 3 to x and 5. So we have 3x plus 15. So on the left-hand side of this equal sign, I would combine like terms. So I have a 2x squared minus x squared. That's just x squared. I have 6x plus x. That's 7x. And then I have plus 10. And that'll be equal to 3x plus 15. So since I still have this x squared, it is going to be a quadratic. So you need everything on one side of your equation, and it should be equal to 0. Okay, so I would subtract 3x from both sides. So I have 4x. And subtract 15 from both sides. Okay, minus 5. So everything equal to 0. Okay, now I do that so that I can factor. Okay, so you can factor this. So again, if you need to use the x method, what adds to 4 and multiplies to negative 5? What are the factors of 5? 1 and 5. Okay, so I would have 5 and negative 1. Okay, add those together, I get positive 4. Multiply them, I get negative 5. So here this would factor into x plus 5 times x minus 1 equal to 0. Okay, once I factor it, I can set each of those quantities equal to 0. Okay, so x plus 5 equals 0, and x minus 1 equals 0. So x is negative 5, or x is 1. Now we do need to check both of those answers. Okay, you need to check both of those answers. So that's your step 3. I'm going to write it over here. Okay, step 3 is over here. So you're plugging in negative 5 into your original. So I would have 2 times negative 5 over negative 5 plus 5. Okay, minus negative 5 squared minus negative 5 minus 10. Okay, that's over negative 5 squared plus 8 times negative 5 plus 15. That's equal to 3 over negative 5 plus 3. Now, before I keep going here, can you tell me which one of these is, which one of these fractions will be undefined? Which one of those fractions is undefined? There's only 3 of them. Which one is it? No. The first one. Okay. This fraction right here is undefined. You have negative 10 over 0. Whenever you have a number over 0, it's undefined, that answer won't work. Okay, that's why you have to check your answers. So since this results in 0 and it is undefined, this x equals negative 5 is not one of your answers. I don't even have to continue solving. I know it won't be one of my answers. Okay, then I do want to plug in 1. Okay, so this one was when x is equal to negative 5. So we're going to now do when x is equal to 1. Okay, so we'll have 2 times 1 over 1 plus 5, minus 1 squared, minus 1, minus 10, over 1 squared plus 8 times 1 plus 15 is equal to 3 over 1 plus 3. Okay, so you do have to check 1 as well. So here I would end up having 2 over 6. Okay, here I have 1 minus 1, that's 0, right? Minus 10 is just negative 10. Okay, I have 1 plus 8, that's 9, plus 15 is 24. And then I'll have 3 over 4. Okay, so now to see what your answer actually is, you can either change these to a denominator of 24, or you can simplify this fraction and then make these 12. But I'm just going to make these both 24. So to get 6 to 24, I'd multiply numerator and denominator by 4, right? So I have 8 over 24. Okay, if I have minus a negative, right, that's just a positive. So I'm going to change that to plus 10 over 24. Okay, and then changing 4 to 24, I need to multiply numerator and denominator by 6. So 3 times 6 is 18 over 24. So we do end up with 18 over 24 is equal to 18 over 24. So when x is equal to 1, that works. So then I could circle or box 1 as my answer. Okay, so again, you have those 3 steps. Okay, step 1 is to find that least common denominator. Step 2 is to multiply each fraction by the least common denominator. And step 3 is to check all of the solutions that you found. Okay, questions? All right, I'm going to stop.